So now when we work on this problem, which is 67, I'll copy the problem from the beginning. You don't have to. 67 on page 610. I have the square root of x to the fifth, y to the third over the square root of xy. I will rewrite everything under one radical as x to the fifth, y to the third over xy. And only now I apply the radical. Both are nice and friendly. And the answer would be? X squared y. Perfect. But if I'm told that x and y can be anything, the only difference will be this. Nothing else. This is an important type of problem. So please choose from 61 through 76 any problem you want. If not, I will. Okay, 73. In 73, we have the fourth root of 96, a to the 10th, b to the third, everything divided by the fourth root of 3a squared, b to the third. I want to draw your attention here for a moment to the previous note. I should have mentioned, but I think it's clear, but I should have mentioned it. Only if radicals have the same index. You cannot condense the cube root with the fourth root. So they have to have the same index. So if you want to put it in parentheses, I will put it here. Assume radicals have same index. So same index. Same index. That was the assumption. Same index. Okay? So let's work on this problem for 1 minute. And if anyone can tell us how to start.
Bring it off to the one thing.
Right, because I see 96 and 3, I see A, and I see B and B. 32. Thank you. So the fourth root of 96, A to the 10th, B to the third, over 3A squared, B to the third. So this is the fourth root indeed of?
Would you say 36?
Yes, 30? No, 32. 9 divided by 3 is 3. 6 divided by 3 is 2.
So 32A
to the A. Very good. And luckily, these two go away. Please write 1 and 1. 1 and 1. Good. So it appears that there is no problem. Other than 32. And we just did 32 a few minutes ago.
Yeah.
16 and 2. So this will be the fourth root of 16 times the fourth root of 2 times the fourth root of 8 to the 8th. It's 313. Anyone who leaves at 314 will have 5 points off the next test. Just kidding. Okay, so see you on Wednesday. So the simplified form. Yes. How much is this?
A to the 2.
Very good. And then the fourth root of 2 has to stay. There is nothing else. Very good. Do we need more of these?
Yes.
Very good. Let's say 75. Let's work on 75 for a minute. Which is the fifth root of 64. X to the 10th, y to the third, and everything divided by the fifth root of 2, x to the third, y to negative 7. Should I use the same index? Why?
They're both 5.
I see, yes, but because I see that 64 and 2 and x and y and y. If they were totally different quantities with no common factors, I would have not bothered to write the same index. It's the fifth root of 64, x to the 10th, y to the 3rd, and the fifth root of 2, x to the 3rd, y to negative 7. Better? So can anyone give us something to write? Yes? Over 2, 32, times x to which power? Very good. Now be very careful. Times y to which power? Yes. 3 minus negative 7. I claim that these two of those radicals, there are 3 radicals in here. The fifth root of 32, the fifth root of x to the 7th, and the fifth root of y to the 10th. 2 of them are nice and friendly, and 1 of them is not. Which one is not?
The middle one?
Yes, because 7 over 5 is not an integer. How will I split x to the 7th? 7 over 5? No. 6 over 5? No. 5 and 2. That's how I know. X to the 5th? Oops.
Sorry.
I'm telling you I can't write today. X is y, and so what happens to, bless you, the fifth root of 32? How much? 2. The fifth root of x to the 5th. The fifth root of y to the 10th. And what is left under the fifth root?
The 2.
X squared indeed. Very good. Excellent. Do we need another of this?
I get to know that.
Now, let me write an intermediate step for everyone to see. Right here, intermediate step. So I will write the fifth root of 32 times the fifth root of x to the 5th times the fifth root of x squared and times the fifth root of y to the 10th. That's why this is 2. This is x. And this is y squared. This is the only one that I cannot take the radical from. And it has to stay at the end. It looks like a puzzle, but it's not difficult. I think factoring is more difficult than this. I think equations or other things are more difficult than this. This is just, it looks like a puzzle. Just use the same rules over and over. Okay, do we need another example like this one? Or can we move on? Okay, very good. So now we need to talk about the distance between 2 points. Distance between 2 points. I just filled this in. And then we'll talk about the midpoint formula. Midpoint. Okay, so let's look at ready? So here is a coordinate system. And let's say I have this point, which is point A, and I have this point, which is point B. And this is the distance between those two, and this is what I want to determine. I want to find a formula for this distance between point A and point B. So I'm going to say that point A has coordinates x1, y1. It's the first point. X of the first point, comma, y of the first point. How do you think we're going to denote the coordinates of point B? Very good. Now I'm going to form a right triangle. We're using a horizontal and a vertical line. So here's a right triangle. Very good, excellent. So I have a right triangle. So I'm left with the green. Everything else I had to throw away. Okay. So now I would like to determine this distance. Can anyone give us this distance? And later on, can anyone give us this distance? So if A has coordinates x1, y1, how much is this distance from this point, the origin, till this point? It's x1. If you want to call it 3, you can. Now, what is the distance between the origin and this point? Right. So now can anyone identify, if we know that this is x1 and this is x2, can anyone give us this distance?
Which one are you putting?
We know that this is x1. We know that this is x2. x2 minus x1. x2 minus x1. Can anyone give us what is this? Very good. Can anyone tell us what this is? Very good. So can anyone give us this distance, which is the length of the other leg?
Y2 minus y1.
Perfect. So using Pythagorean theorem,
I definitely remember that.
the hypotenuse squared equals the sum of leg 1 squared plus leg 2 squared. So tell me how to fill this in. What is the hypotenuse for us? The distance, d squared. Very good. What is leg 1 squared? Very good. What is leg 2 squared? Now, I need to apply something to both sides in order to get just the d. And the answer is I have to apply the square root to both sides. The left-hand side is d. Is there any way to simplify the right-hand side? Don't answer before you think of the properties that we discussed in chapter 10. Is there any way I can simplify the right-hand side? The square root of this plus this. Say it again. So that's my question. Okay, Jesse, can I get that just one more time? Sorry. I'm not taking it away from you. I just want to point out something that is super crucial.
The whole thing?
No, just you can find it.
I can find it.
That's your test for today.
What? This is not a good test. Hold
It's a
on.
very good test. Exactly. The next page.
This one?
The next page.
This one?
Yes, that's one.
Okay.
So one more time. Can I simplify the square root of blah squared plus blah squared?
No.
I can never do that because the square root of something plus something else does not exist. I cannot split this into this, right? So this is the formula and no one can simplify it in any way, shape, or form. This is it. Okay? We cannot simplify this. This is x2 minus x1 squared plus y2 minus y1 squared. Done. No one can touch this. So now the other thing is this line, the segment that connects A to B, has a point right in the middle called the midpoint, M. It's very easy to form triangles here, right triangles here, and one here. I don't want to put it on the same graph. And we will be able to determine the coordinates of the midpoint. Here they are. The sum of x's over 2 and the sum of y's over 2. What y's? What x's? Of A and B. So x1 plus x2 over 2 and y1 plus y2 over 2 will always give us the coordinates of that point that divides the segment into two equal parts. So now give me any 2 points. Let's find the distance between those two. Any points you want. And also find the coordinates of the midpoint. Also some negative in there, anywhere. Excellent. So I know now that this is x1, y1, and x2, y2. We know that, correct? So we are asked to find the distance between these two, which I know the formula. I copied the formula right now. x2 minus x1, everything squared, plus y2 minus y1, everything squared. Underneath, I will put all those numbers carefully. What is x2? What do I write under x2?
3.
Perfect. What do I write under x1?
Negative 2. So
Excellent.
2.
So what do I write under y2?
2.
What do I write under y1?
5.
Please make a note. You cannot come up with a negative number from here. Why? Because it's squared. You cannot come up with a negative number from here. Why? Because it's squared. So how much is 3 minus negative 2?
3 plus 2.
3 plus 2, which is?
5.
And if you square that?
25.
Very good. So d equals the square root of 25 plus. You don't do anything, you wait. How much is 2 minus 5?
Negative 3.
Negative 3 squared.
2. Oh, 6. Sorry.
9.
Yeah.
Very good. So then from here, I know that d is the square root of 34. Done. You cannot simplify any further. Please do not say that this is the square root of 25 plus the square root of 9. That is incorrect. We know that. Good. Let's find now the midpoint. The midpoint has the sum of the x's over 2. And then the sum of the y's over 2. Please add negative 2 to 3. 1. Please add 5 to 2.
7.
So these are the coordinates of the midpoint. This point 1/2, comma 7/2. If you plot it on the line, it will give you 2 equal segments. It will bisect, we say, that segment, line segment. We will divide it in 2, exactly in half. Okay, I'm ready to choose another pair or ordered pairs before we move on. And this is, I just opened the book to move on to the next level or section. Look what this says. Concept check. True or false? False. The square root of the sum of 2 square roots is not the square root of the sum. So please make a note of that. Okay, so can anyone give us another pair of ordered pairs? Okay, -3, -10, and -4, 7. Please determine the distance and please find the coordinates of the midpoint. Okay, 2 minutes. the first part of your video started because it takes an hour. It takes so long to upload. Okay. First, I recommend write the formula. x2 minus x1 squared plus y2 minus y1 squared. Then identify x1, y1. So x1, y1, x2, y2. Then write underneath, in order not to make a mistake, -4, -3, and 7 and -10. Perform the calculation square, because if you write it down as a negative number and then you square it, you may forget that it's a positive number. So then D equals, how much is -4 minus -3? -1, right? -4 minus -3 is -4 plus 3, which is -1. -1 squared, which is 1, plus 7 minus -10. 7 minus -10 is 17. 17 squared. So this is the square of 1 plus. How much is 17 squared? Very good. So this is the square of 290. Since 29 is a prime number and 10 is 2 times 5, you cannot further simplify the square root of 290. This is it. Any questions? Any questions? Now the midpoint. Please add these two values of x. What do you get? Very good. So it's -7 over 2. Please add up these two values of y. Very good, which is -3/2. So the midpoint is -7/2, comma, -3/2. Any questions? Okay. Now we add and subtract radical expressions in 10.4. Adding, subtracting, radical, or radicals. Of course, they must be like terms. So let's see what we can add and when we cannot add. Okay, on page 615, I would like to start with an easy one, just a warm-up. 2 on page 615. And this is the square root of 27 minus the square root of 75. I would like to do this, and you tell me whether, don't write it, and you'll tell me whether I am allowed to do this or not. No, we just discussed that. I'm not allowed to do something like this. Very good. But I can simplify each radical by itself. Well, I know that the square root of 27 is not an integer, but I've learned already that I can split it to simplify it. I know the square root of 75 is not an integer, but I already know now that I can split it to simplify it. And this is useful. This is useful for the future in math, your future in math. So the square root of 27 is this times this. Very good. So I'm going to write 9 times 3. And 75 is this times this, and one of them is a perfect square, the other one is not. Very good. Excellent. So now I know how to simplify the first radical. So what will I write? Very good. 3, the square root of 3. Minus 5, the square root of 3. Here's what I say now in my head. 3 apples minus 5 apples, because they are like radicals. So 3 apples minus 5 apples is -2, the square root of 3. Bless you. Now let's work on number 5, which is 2, the square root of 50, minus 3, the square root of 125, plus the square root of 98. Simplify each and every radical to the maximum, and then see if they are like radicals. If they are like radicals, then combine them. If they're not like radicals, then leave them alone. Ready? How do you split 20? How do you split 50? 25 and 2. How do you split 125? And very good. And how do you split 98? 49 and 2. Excellent. Very good. Excellent. Good. So now be very careful if you'd like to see this, and let's do this part together. For everyone to see, allow me to write it one more time. You don't have to write this. But I will write 2 times the square root of 25 times the square root of 2. This is this. Now I'm here, minus the square root of 25 times the square root of 5. I reach the plus now. Plus the square root of 49 times the square root of 2. Now, can anyone tell us what this is? But it has to be multiplied by 2. So what would you tell me to write as the simplified form of this radical? Do you all agree with 10 the square root of 2? Okay. Now, how much is this? But I have to multiply by 3 that has a minus in front. So what should I write? The square root of 5. And finally, this is, I reached plus 7, the square root of 2. I claim that only 2 of these radicals are like radicals. That I can say 10 apples plus 7 apples. But the square root of 2 and the square root of 5 are not the same. So the middle one will stay as is. But I can combine these two. 10 apples plus 7 apples is 17 the square root of 2 minus 15 the square root of 5. Very good. Now please choose anything you want from literally 1 through 34. On page 615 and page 616. I would like to choose 26 before you choose the next one. The square root of 4x to the 7th y to the 5th plus 9x squared, the square root of x to the 3rd y to the 5th minus 5xy, the square root of x to the 5th y to the 3rd. Yeah, this is a lot of work. Because if I ask you, are these like radicals? You should say, I have no clue. Give me time. I need to simplify each radical. And after I simplify each radical, I'll tell you whether they are like radicals or not. So the square root of 4, x to the 7th, y to the 5th. Oh, sorry. Plus 9x squared, the square of x cubed, y to the 5th, minus 5xy, the square root of x to the 5th, y to the 3rd. So we have to take each and every one of them separately, simplify them, and then we'll decide whether those are like radicals or not. Are we working on this? Nothing is friendly here. Nothing. Because nothing is divisible by 2. 7, 5, 3, 5, 5, 3. You cannot. This is not an equation. This is like, imagine I have $10 in my pocket and I'll say, oh, let me square that. It's not an equation. You can only square both sides of an equation. You cannot square top and bottom if you have something like this, 2/3. You can say, let me square this. Oh, it's the same with 4/9, because it's not going to be the same. Good. So the square root of 4, that is friendly, which is 2. But the square root of 7 has to be presented as the square root of times the square root of. Bless you. I'm good. Very good. X to the 6th and x. And the square root of y to the 5th will be split into? Very good. Plus 9x squared. Then square root of and square root of. Very good. X squared. Yes. And now y to the 5th. Very good. And minus 5xy for x to the 5th. And then for y to the 3rd. What do I write for x to the 5th? X to the 4th and x. And for y to the 3rd? Yes, 2 and 1. Okay, let's analyze what will go away as a radical. Where the radical will go away. This will go away as a radical. This will go away. This will go away. This will go away. This and this. Everything else will stay. This will stay. This will stay. This will stay. This will stay. 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 All these stay. Good. Ready. Very good. 2x to the 3rd. Very good. And now these two will stay as is, the square root of xy. Plus 9x squared. But there is another x from here. 9x squared with x. 9x cubed. And from here? Very good. However, these two will stay. They cannot go anywhere. Can anyone simplify the third term for us? Which is minus 5 what? There is an x squared from here with an x. Very good. Very good. And these two will stay as they are, a square root of xy. Now I look at these three terms and I analyze whether they are or they are not like radicals. So let's analyze each portion. Please pay attention for a moment. The radical part is identical. Would you agree? Would you agree that they have the same variables in front? Do you agree that they have the same exponents? All those variables have the exact same exponent. X cubed, x cubed, x cubed. Y squared, y squared, y squared. Yes? So now in my head, I perform the following operation. 2 plus 9, or 2 apples, plus 9 apples, minus 5 apples. 6 apples, I agree. So this is 6, x to the third, y squared, the square root of xy. This is a little bit taking it to extreme, but it has everything you need in there. Okay, would you like to choose another? We still have about 14 minutes. On page 616. Now, after this section, there are 3 sections left. 2 require some time. The third one is very easy. Okay, so 5, 6, and 7. And then we'll set up the exam. I'm not sure how long I need for these, so I still have 10.5 through 10.7, so 3 sections. So allow me to look at my phone just because I don't have a calendar in front of me. So I see that will be test 2. So I'm looking at the calendar. Today's the 10th. I'm estimating we will review on the 19th, and the test will probably be on the 24th. So I'm going to say October the 24th. Test 2. This is tentative. Okay? Tentatively, test 2, 2 weeks from today. October the 24th.
And the tests are, you're going to have everything from the first and the second?
No. So test 2 is only on 9.2 through 9.4, 10.1 through 10.7.
Oh, cool.
Just remember, every weekend I'm kindly asking you to redo all tests and quizzes. You will be super prepared for the final exam if you do that every weekend. Okay? You will struggle if you don't. Potentially. That's my explanation. So forgive me if I'm wrong, because I'm sure that my method does not work for all students. Okay, would you like to choose from 27 through 34, or I will? Okay. Thank you for the vote of confidence, and I will look at, yeah, 32. Very easy. 3, the cube root of 5, plus 4, the square root of 5, minus 8, the square root of 5. Are these like radicals? Only the last 2. So I will write 3, the cube root of 5, and then 4 apples minus 8 apples. You cannot do anything else to this. This is it. Let's look at the division. 42. The cube root of 3 divided by 10 plus the cube root of 24 divided by 125. Can you simplify the first radical in any way, shape, or form? No. So the whole effort is right here. So first I will try to simplify and see if these have common factors, because I hope that they do. So 24 and 125 have a common factor of? Maybe they don't. Oops, I meant to write plus. Maybe they don't. So 24, how will I split it into this and this? Remember, the index is 3. You cannot say 4 and 6 because the index is 3.
8 and 3.
8 and 3, I agree. What about 125? Say it again. 25 and 5. Excellent. So then we have the top. The cube root of 8 times the cube root of 3. Bless you. Well, actually, it's the cube root. I'm sorry. I was still thinking of so sorry. I was thinking of the square root. But the cube root of 125 is exactly 5. 5 raised to the third is 125. Sorry about that. I confused you. My mistake. So this is the cube root of 3 over 10 plus, how much is the cube root of 8?
2.
2 the cube root of 3 divided by 5. In order to add these fractions, I have to find the
Multiply by 2.
Yes, I have to find the least common denominator. Perfect. And I multiply the first quantity by 2. Can anyone tell us what to write at the top? Of course, the cube root of 3, but what else? Plus, yes, for the cube root of 3. Are the two radicals at the top like radicals? So then I say 1 apple plus 4 apples, and I get 5 times the cube root of 3 divided by 10. But now I see that 5 and 10 have a common factor of, so 5 divided by 5 and 10 divided by 5 is 2. So the cube root of 3 over 2. That's the final simplified form. Now the next set is more complicated. And that's the last set for this section through 76. And yes, this is useful. So I'm going to start with 48. And that is the square root of 5 and quantity, the square root of 15 minus the square root of 35. What would you, we're asked to simplify. What would you think of doing first? You could say, well, I'm hoping that I can subtract first, right? The square root of 15 minus square root of 35. However, they are not like radicals. They cannot be further simplified in any way, shape, or form. So the answer is no. If you're thinking of combining these two, you would say, sorry, I can't. Distribute. That's my only chance to simplify. So I will distribute this and this. So now you can write the intermediate step, and I will write it. The square root of 5 times the square root of 15 minus the square root of 5 times the square root of 35. What I would like to do, instead of multiplying 5 by 15 and get 75, and 5 times 35 and get 170, I would rather do this. This product has the square root of 5 times the square root of 5 times the square root of 3. And this product has minus the square root of 5 times the square root of 5 times the square root of 7. Because it's very easy to see what I should do next. Instead of multiplying, get a big number, and then going backwards and saying, how do I simplify this? But yes, you can multiply if you want to. So what will be the simplified form of this expression? From now on, we should remember that the square root of 5 times the square root of 5 is 5, because it's the square root of 25, which is 5. So whenever I multiply the square root by itself, I get the same thing without the square root. So 5 the square root of 3 minus. Are these like radicals? Can you combine them? No. Because I can't say 5 apples plus 3 minus 5 apples. I can't. They're not the same. Now, let's look at 53. Last one and I stop, I promise. But please don't start packing. I'll give you a second to pack. 3 the square root of x plus 1. Last one. Now you would say, okay, let's combine like terms. Well, I can't. Let's combine like terms in the other one. I can't. So what will be the only option here? FOIL. Very good. So I have to distribute this to the first term and then to the second term. And then I have to distribute -5 to the first term and then to the second term. When I distribute 2 the square root of x to 3 the square root of x, please be careful. You multiply the outsides together and the insides together, as long as they have the same radicals. So first you have to multiply 2 by 3 and you get 6. Exactly, because the square root of x times the square root of x should be the absolute value of x, but we assume everything positive. So 2 times the square root of x times 3 times the square root of x is indeed 6x. So I distributed this quantity to the first term. Now I have to distribute it to the second term. What do I write?
Wait, what?
2 times 3 is 6. The square root of x and the square root of x is the absolute value of x, but everything is positive. Now I'm distributing this term to 1.
Is the square root?
Sign.
What?
Plus.
Oh,
Good. And now I distribute -5 to the first term. What do I get?
minus 15.
Exactly, the square root of x. And the final?
-5.
Good. Now I look and realize that 2 of those are like radicals. What will you tell me to write as the final simplified form? And no one can do any further.
6x minus 13 to the square root of x. What is that? Minus 5.
I could have not said it better. Thank you very much. If you have questions,